Next we are going to see about equivalent circuit of induction motor. Here the transformer works the principle of electromagnetic induction. The induction motor also works the same principle. The energy transfer from stator to rotor of induction motor takes place entirely with help of flux, mutually linking the two. Thus, the stator acts as a primary while rotor acts as a secondary when the induction motor is treated as a transformer. If E1 is the induced voltage in stator per phase, E2 is the rotor EMF induced per phase. K is equal to rotor turns per stator turns. Therefore, K equal to E2 by E1. The EMF in stator phase, while E2 is the induced EMF in rotor due to the mutual induction at standstill. In running condition, the induced EMF rotor becomes E2R, which E2R is the rotor induced EMF in running condition. R2 is the rotor resistance per phase. X2R is the rotor reactance per phase. R1 is stator resistance per phase. X1 is the stator reactance per phase. So, when the induction, this is a diagram for the equivalent circuit of induction motor. When the induction motor is on load, it draws a current from the supply to produce a flux in the air gap to supply the iron losses. So, IT is a active component which supplies a no load losses. IM is a magnetizing current. Therefore, I naught equal to IC plus IM. The stator and the rotor side are separately by an air gap, so I2R equal to rotor current in running condition. So that is equal to E2R by Z2R, that is equal to S into E2 divided by square root of R squared plus X squared by 2. The rotor impedance, so it can be assumed the equivalent rotor circuit running condition has this reactance X2. The old X2 but variable X2 by S indicated in the above equation. R2 by S is equal to R2 plus R2 by S minus R2. So that is equal to R2 by S is equal to R2 plus R2 into 1 by S minus 1. That is equal to R2 plus R2 into 1 minus S by S. So reflect the rotor current as reflected component on the stator side, which is I2R. That is equal to I2R dash is equal to K into I2R. Therefore, RL by K squared is equal to R2 dash by 1 minus S by S. So approximation equivalent circuit. The power equation from equivalent circuit is equal to, with the reference approximate equivalent circuit, we can write the power equation Pm equal to P2 minus PE, that is equal to 3 into I2R dash square R2 dash by S minus 3 into I2R dash square R2 dash. That will be equal to 3 I2R dash square R2 dash 1 minus S by S. So therefore T equal to Pm by W, that will be equal to 3 I2 R dash square R2 dash 1 minus S by S the whole divided by 2 pi N by 60. Thank you.